Hi everyone. Today let's solve a Leetcode question called minimum height tree. Well, the height tree is defined as the number of edges on the longest downward path between the root and leaf. In other words, the number of edges or the distance between the root and leaf. And we want to list all minimum height trees root labels, in other words, central points in any order. Well, the question looks very long, so let's check example here to help us then. So you see the example 1, we have 4 nodes, 0, 1, 2, 3. And we see the edge node tell us, okay, 1 connected to 0, 1 connected to 2, and 1 connected to 3. So you see, it's obvious that the root or the central is 1. And after that, let's check example 2. Example 2 has 6 nodes, all the way from 0 to 5. And the edge to is 3 connected to 0, 1, 2, 4. And 4 is additionally connected to 5. So central point can be both 3 and 4 because they are both distance 1 from the leaf node. Okay, so for this kind of graph problem, we can actually use adjacent list to record the connection information in the edges. So let me use a graph joining here to show how to solve this kind of problem. Okay, so I'll use a green color here and write it on the right side. So we'll build the adjacent list. The adjacent list with a key for both nodes. So let me write it out here as 6 node, right? The first will be 0 and 1. We have 2, we have 3, we have 4, and we have 5. Okay, so these are keys. And write the key here. And we also want to add values, right? And you see, for 0 we have connected to 3, so the value is 3. 1 connected to 3, so value also 3. And for 2 also we have 3. And after that, for 3 we have slightly longer values. We have both 0, we have 1, we have 2, and we have 4, since we have 3, 4 here. And for 4, we have 2 nodes. 1 is 3, and 1 is 5, since we have 4, 5 here. And for 5, we have only the 4. Okay, now we have finished the mapping position for adjacent list between the key and values. Now the next step is to determine which ones are leaf nodes, which we will remove in the next step. Okay, you see all the leaf nodes have only one value in the adjacent list. So this one, 0 is the leaf node. Let me use different color here. Okay, so red one indicates this is the leaf node. And 1 is the leaf node, 2 is the leaf node, 3 has 4, so not leaf node. 4 it has 2, so not leaf node by far. And 5 have only 1, so this is leaf node. So next step after determining the leaf node, we have to remove the leaf node from our graph list, so we can further determine the central points in the next step. Okay, so let's use different color here. Let's use blue color to indicate all the leaf node. So we will remove this node because it's leaf, and we'll remove these 3 nodes. Okay, this node will be removed, this node will be removed, and this node will be removed, right? Okay, once we remove this node, we have to update our JSON list. So let's check which one to update. Well, after the first step, for remove, 0 is no longer exists, so we'll clean this out. 1 is also not exist, so clean this out. And also 2 does not exist, so clean this out. And we also need to check the 3, right? Because after that 3 has only the 4 as its element. Okay, now we're only 4. And for 4, now we're only 3. Oh, sorry. Write it out. Only has 3. And for 5, 5 doesn't exist, so clean it out. Okay. And in this step, we want to see, okay, 3 has only one length 1 for the valve, and 4 only have length 1 for the valve. In this case, we have found the central point, and we have to turn 3 and 4. Okay, so let me repeat again. If we clean out the leaf nodes and found, okay, both nodes has length 1 for the valve, this means both nodes are central point, and we just return them in the result array. So let me use a different color here. we want to return a result array containing these two nodes, 3 and 4, and we are done. Okay, now finish integration, let's dive into the coding part. So this code is slightly long, so I will write this video, write the code before recording this video. So the first case we have to consider always for this graph node is the corner cases. So far, okay, the numbers nodes is smaller than 2, so maybe the numbers nodes is 0 or 1. If that's the case, 0 will be always included in the central node. So we just return 0. And after that, we want to build the graph of a JSON list. So let me scroll it down. You see we will use this function in Python. So it will build a number of sets with the length of n, right? So there are total n sets in this array. And after that, we want to build the JSON list using the edges. So we'll point both source to a destination and destination to source. So in this way, for example, in here, 1, 0 will be exactly same with 0, 1 for sequence. And after that, we want to build a curl with all the first level nodes, in other words, the leaves. So we just call this Python function. We found, okay, if the length of JSON node is equal to 1 to this step, this means this will be the leaf node, and we want to include it. And after that, we want to keep removing the first level, or in other words, the current leaves, until there are only 1 or 2 remains. This means we have only the central point remains. If that's the case, we first will pop all the neighbor nodes and remove its edges. You see here we will deduct the n by the length of leaves, which is the current leaf node, and we want to go through all the leaf nodes in the current level, and we use this function. So first we pop the neighbors and find all neighbors first level nodes and remove it. So we remove both the edges and the first level node. You found, okay, at this time, the length of adjacent list of this neighbor is equal to 1. This means, okay, this neighbor is exactly the central point, and we want to append it to our result array, and we call it leaves.next, right? Because maybe we're updating it in the next iteration. And after that, we'll assign leaves.next to leaves. So in the next iteration, we'll use leaves.next in the current iteration. And finally, we return the leaf if this entire while loop is finished and we get all the central point in the result array. Okay, now let's submit the result to see it works. Okay, see the time capacity memory usage of this question is not so bad. And overall, the coding part is long and explanation takes some time. I think it's relatively easy to understand. Okay, if you like this video, please subscribe to my channel, and I'll see you next time. Thank you.